Okay, so here goes your review for Unit 2. Hopefully this helps you prepare for your test. If you have any questions as you're working through this, let me know and I can help you as best I can. Shoot me an email or whatever, okay? So the first couple of questions you need to solve using any quadratic technique. Remember that your options are square rooting, factoring, completing the square, or the quadratic formula. The quadratic formula you need to have memorized. You will need to use it, so make sure that you know what it is. Let's work through a couple. So on this first one, I can see clearly that I have no x term, so I'm going to use square rooting for this. Before I can square root, I have to get the parenthesis part with the square alone. So I'm going to start by subtracting 5 from negative 25. Then I'm going to divide by 4, which is negative 30 over 4, which I'm actually going to leave. I'm not going to reduce right now. And I have a reason. I'll tell you in a second. Now I'm going to square root both sides. That gets rid of the squared on the left side, and I'm just left with x minus 3. When I square root negative 30 over 4, what I'm really doing is I'm square rooting them separately. Okay? I'm square rooting negative 30, and I'm square rooting 4. And here's why I didn't reduce it. Because 4 has a nice square root, it's 2. On the top, I have that negative, so I just need to pull out the I. And I've got plus or minus I squared of 30. Now my last step is to add 3 to the other side. X equals 3 plus or minus I squared of 30 over 2. I could also change that 3 to a 6 over 2, so that I can then add it. And really, I probably should. So that it is all one fraction. So here is my solution for that. This one here, square rooting is out because I have that middle x term. I'm going to start by setting this equal to 0 so I can kind of see what I'm working with. So I'm going to subtract 15 because I want to see, first of all, can I divide anything out? Is there anything that goes into all 3 of them? The answer is no. Factoring might be an option here. I am going to check the discriminant real quick. I don't know if you remember this. The b squared minus 4ac is 196 plus, and then whatever 4 times 8 times 15 is 480 plus 196 is 676. If I can square root that, then I know it's factorable. And the square root of that is 26. So this is factorable. So let's try factoring here. Let's see. 8 is 4 and 2. Let's try that. And 15 is 5 and 3. Oh, 5 and 3. Here we go. 6, 20. And if I subtract that, 6 minus 20, I get negative 14. There we go. So then remember, I'm going to solve each of these. So x equals, in my first parenthesis, I'm going to take the opposite of 3 divided by 4 is negative 3/4. And then the second parenthesis, I take the opposite of negative 5 over 2, which is 5/2. And those are my two solutions. We got kind of lucky with this one because we could factor it. Remember that when a is bigger than about 5, you really probably just want to use the quadratic formula. I have the distinct advantage of having written this problem so that I know it's factorable. But kind of pay attention to those clues, okay? Let's do one more. This time we've got 6x squared plus 2x, and then I'm going to subtract the 1 right away and get plus 2. Now, I can right away, I can divide everything by 2. So I'm going to do that. I'm going to get 3x squared plus x plus 1 equals 0. I'm thinking about factoring again, but there's no way I can use factors of 3 and 1 to make 1. Like, that just won't work. So I am going to have to either complete the square or use the quadratic formula. And remember, we talked about completing the square works if a is 1. It is not. So I'm just going to use the quadratic formula. So 3 is my a, 1 is my b, 1 is my c, I'm going to plug them into that formula, which again, you need to have that memorized. And I'm going to put all the stuff in here. 2 times 3 is 6. So when I work inside my radical here, I've got 1 minus 12, which is negative 11, means I need an I in my answer. There's nothing I can simplify because that radical 11 can't be simplified at all. So I'm going to leave this as my solution. Okay, so make sure you know which quadratic technique is best to use. Again, you can use the quadratic formula for everything. I don't suggest it, but you can because that always works, but kind of know which ones work better for which situations, okay? Number 4, Charlie Brown finally kicks that ball that Lucy's always holding for him. His kick follows a path modeled by the equation given there. This is telling you that height is a function of time. It means height is your y and time is your x. What is the highest point that the ball reaches? How long does it take the ball to hit the ground? So I'm just going to graph a quick picture here. The ball starts here, Charlie Brown kicks it, it goes in the air, and then it comes back and lands, right? So the first question is, what is the highest point that the ball reaches? That would be the apex of the curve, or as we know it, the vertex. So we need to figure out what is the vertex of this parabola. Remember we have that formula, negative b over 2a. We can use that with our equation. So negative 40 over 2 times negative 15 gives us 4/3. Now remember, that's the x part of our vertex. And what did we say the x was here? X is time. The question is, how high does the ball go? So we need to find the y value of this vertex. How far up is it? We do that simply by putting 4/3 into the equation for t. So I'm going to substitute that in. And then I'm just going to simplify. 4/3 squared is 16 over 9. 16 over 9 times 15, negative 15, is negative 80 over 3. And then 40 times 4/3 is 160 over 3. Add those together and I get 80 over 3. We don't usually talk about time as 80/3 of a second. So I'm just going to divide that and I get 26.7. And this is height. We can assume it's probably in feet. I know we didn't give any labels, but distance is usually measured in feet per second. So we're going to say that that ball went 26.7 feet high. Okay? Now the other question is, how long does it take the ball to hit the ground? Well, look at this parabola that I drew. The ball hits the peak or the vertex at 4/3 or 4/3 of a second. And then it hits the ground that exact same amount of time later. Remember that the vertex is always in the middle of the parabola. That's where our axis of symmetry is. It goes right through the middle. So 4/3 is half the time that the ball is in the air. Then it would simply hit the ground at 8/3 of a second. Now again, we don't usually talk about it that way. So let's just do 8 divided by 3 and we get 2.7 seconds. So after about 2.7 seconds, the ball would hit the ground. Okay? Sometimes it helps to draw a picture and you can kind of see what you're talking about and put all the pieces together. This one's kind of interesting, especially if you can remember that negative b over 2a formula. That's really helpful. That helps you find the vertex. Once you get the x, then you plug it in to find the y. All right, number 5 here, state the degree of the name and all the possible zeros of the function there. Remember, degree is the highest exponent, so that would be 2 in this case, which means that this is called a quadratic. Our favorite. You do need to know quadratic, cubic, quartic, all those names. You need to know what the different graphs are called, okay? Now, to find all of the possible roots, we're going to take all of the factors of p, which is 3, plus or minus 1, plus minus 3, and divide them by all the factors of q, which is 2. I'll label this for you so you can see. Plus or minus 1, plus or minus 2. And we're going to get all of our possible factors that way. So first I'm going to start with 1 divided by 1 is 1. 1 divided by 2 is 1/2. 3 divided by 1 is 3. And 3 divided by 2 is 3/2. So we actually have 8 possible roots. Remember, the degree is 2, so we only have 2 of them that actually work, but we have 8 possibilities that we could try. Okay? Number 6, describe the leading coefficient degree and how that affects the graph of the polynomial. First of all, let me tell you the word describe means use your words, okay? So you're describing in words what is going on with this graph. I can see here that the leading coefficient is negative. That tells me something about the graph. The degree is 4. That tells me something about the graph. So what I'm going to do first, I'm just going to sketch a graph real quick. This is a 4th degree, so I know it has 3 turns or 3 humps. And I know the leading coefficient is negative, so it ends down. So I'm actually going to work backwards, okay? So I'm going to start down, I'm going to go up, 1 turn, 2 turns, 3 turns, and down. I can also see that this has 4 roots because it's a degree of 4. So what I'm going to describe in my words is that the leading coefficient is negative, so the graph ends down. The degree is 4, so there are 4 roots, and 3 humps. Okay? So when I'm asking you to describe something to me, I'm asking you to describe what the leading coefficient and what the degree do to the graph of that function. I want to know specifically that it ends down or ends up. I want to know how many roots it has. I want to know how many humps it has. That's what I'm looking for when I say describe. And I want you to tell me that in words, okay? So if you want a graph, that's fine, but I need you to describe that to me using your words. Is x minus 3 a factor of the polynomial there, and how do you know? So we know because we're going to do synthetic division to figure this out. So I'm going to be dividing by 3, and I'm going to line up my coefficients. Remember that I need to have 1 for each position. So I have an x squared, an x, and a constant. I'm good, I don't need to add any zeros. So I'm going to bring down the 2, and I'm going to get this, okay? Oh, I messed up. Hopefully you caught that. I should have, and this is why I try to be careful about my formatting. It's -5. There we go. Let's try this again. So we're going to bring down the 2, 6, 1, 3, 0. Here we go. So the question is this a factor? The answer is yes. How do we know? Because the remainder is 0. Okay? I am looking for you to tell me that the remainder is 0 or the remainder is not 0. I don't want you to say yes because it's 0. You need to be specific and descriptive, okay? The reason we know something is a factor is because the remainder, this number behind the wall here, is 0. We know it's not a factor if that remainder is anything other than 0. Remainder is the key piece here, okay? So make sure that when you are explaining how you know, which is a point, so don't forget to do that, you tell me that it's because of the remainder. Now looking at this one, we are going to have to divide here. And it says express your answer in terms of x squared plus 4. I'll explain that once we get our answer. Remember we talked about when you're dividing, you cannot do synthetic division if your dividend is not linear. And this is not. We have an x squared, which means that we must do long division to figure this out. So we're going to set this up. Got 3x4. Now notice I jumped from a 4 to a 2. I'm missing my cube. So I need to put that in with a 0 so that I have a placeholder. Same with my x term. I'm missing an x term, so I'm going to put a 0 in there as well. Okay, now the first thing I want to do, what's going to multiply by x squared to give me 3x to the 4th? 3x squared. Remember that you're trying to find what to multiply by so that you can cancel out this first term. Because 3x squared times x squared is 3x to the 4th. When I multiply, I also have to multiply 3x squared times 4, which is 12x squared. And then I'm going to subtract. Your first two terms should cancel out. If they don't, you did it wrong. So make sure that you're multiplying by the right thing to get them to cancel out. 0x cubed minus nothing is 0, so I'm not going to bother with that. 11x squared minus 12x squared is negative 1x squared. Then I'm going to bring down the rest of this stuff. Now my question is, x squared times what is going to give me negative 1x squared? Well, negative 1. So I'm going to multiply that again. Negative 1x squared and negative 1 times 4 is negative 4. Now I'm going to subtract. These first terms again cancel each other out. And then when I take negative 4 minus negative 4, I also get 0 here, which means I have no remainder. So my answer is 3x squared minus 1. Now, when it says express your answer in terms of x squared plus 4, what that means, let's say you did negative 4, whatever, and you got a remainder of 8. Instead of writing R8, we would write our answer as 3x squared minus 1 plus 8 over what we were dividing by, x squared plus 4. This is writing it in terms of x squared plus 4. That's what that means, okay? So if you have a remainder, don't forget to put it over whatever you were dividing by. That's a really important piece. Number 9, perform the indicated operations. So we are dealing with complex numbers here. We're just adding and subtracting. So I'm basically just combining like terms. So I'm going to add my real parts first. So 4 minus 3 is 1. Negative I minus 2i is negative 3i, plus 5i is plus 2i. The only thing I would say is be really, really careful about your signs when you're doing this, okay? Make sure that if you're subtracting a quantity, you subtract all of the pieces that are inside it. So looking at this next one, I have 9 plus 3 is 12. And then I have negative I plus 7i minus 2i is 4i. And there we go. I'm done with that. Okay, so adding and subtracting is pretty easy. Just watch your signs on that one. Multiplying, a little different. Remember we talked about the box is super helpful here to help you organize everything and make sure you don't miss something. So I'd really suggest that you use this. Multiply all of the pieces. And then when you get to the end and you have that I squared, don't forget to change that by multiplying your coefficient by negative 1. Because then you can combine your like terms. This is an I, by the way, not a 350. So first I'm going to add 30 plus negative 14, which is 16. And then I'm going to add negative 35i minus 12i is negative 47i. So once I'm done multiplying, I just combine like terms and make sure you're writing it in order. So it's a plus bi. Your complex or your imaginary part should always come second. Your real part should always come first. So on this one too, I'm setting it up. I'm going to multiply through and get all of my pieces. I'm going to remember to change that 27i squared into a negative 27. And then I'm going to add my like terms. So I get negative 47. And then 36i minus 15i is 11i. Okay? So again, multiplication, just be really careful about that I squared piece. Don't forget that. And then make sure you're combining your like terms correctly, okay? Rationalizing the denominator. This is where we multiply by the conjugate of the denominator. On this first one here, I'm going to multiply by 3 minus 2i on both the top and the bottom. On the top, I'm going to multiply that out, so it's 15i minus 10i squared. And then I will simplify that in a second. Remember on the bottom, we talked about you multiply these two, you multiply these two, so we get 9, and then we get minus 4i squared. This becomes a plus 4, and I get 13 in my denominator. You should always get a number. If you end up with an I there, something went horribly wrong, and you didn't rationalize correctly. So make sure that your terms cancel so that you only have numbers left, okay? On the top, I'm going to simplify this negative 10i squared into 10, and then plus 15i. Check real quick and make sure that there's nothing you can factor out. I can't. 10, 15, and 13 have nothing in common, so I am done with that. Let's rationalize in this next one. We're going to multiply by 5 plus I. And I'm going to do that on both the top and the bottom. So on the top, I get 30 plus 6i. On the bottom, I get 25 minus I squared, which is 25 plus 1, 26. So now I have 30, I have 6i, and I have 26. I can divide all of those by 2, and I should. So 15 plus 3i all over 13. This is an I, by the way, not a 60. That's a little confusing, so let me rewrite this so it looks a little bit better. This was a 6i. Okay, so I divide out everything they have in common, which in this case is 2, and I simplify it to 15 plus 3i over 13. You are going to have to rationalize the denominator, so make sure that you know how to do that. Find the conjugate, multiply it out. All right, number 11, find the roots of the polynomial. Let's start with our possible roots. So we're going to take all the factors of 10 divided by all the factors of 1, which is nice and easy. So it's really just the factors of 10, which are 1, 2, 5, and 10. Now we're going to do synthetic division to see which of those roots might work. So I'm going to pull out all my coefficients, 1, 10, 3, negative 10. I don't need any zeros because I have a position for each degree. I'm going to start with 1, okay? 1 times 1 is 1, plus 10 is 11. 1 times 11 is 11, plus 3 is 14. And 14 plus 10 is not going to be 0. Remember that I'm looking for a remainder of 0 here. That's how I know it's a root. So I'm going to move on to negative 1. Negative 1 times 1 is negative 1 plus 10 is 9. This is negative 9 plus 3 is negative 6. This is positive 6 plus negative 10 is negative 4. So that doesn't work either. So my 1s are out. I'm going to cross those off, and I'm going to try the 2s. 1 times 2 is 2, plus 10 is 12. This is 24 plus 3 is 27. That's going to be 54, which does not give me 0. Now I'm going to try negative 2. This negative 2 times 1 is negative 2, plus 10 is 8. Negative 16 plus 3 is negative 13. And that gives me 26, which again is not going to be 10. So I'm going to cross that off as well. So I'm going to get loose on factors here, but let's try a couple more. Let's try 5. So this is 5 plus 10 is 15. This is 75 plus 3 is 78. Clearly that's not going to work. Maybe negative 5 will. So here I've got negative 5 plus 10 is 5. Negative 25 plus 3 is negative 22. And that gives me over 100. So that's not going to work either. So we're kind of running low on some roots here. We can still try the 10s and see if that works. Otherwise, we're looking at we probably have some irrational roots here that we, as of right now, don't really know how to find. So let's try 10. I'm going to rewrite my coefficients because I don't have enough room here. 1 times 10 is 10. That's a 20. Whoops. 200 plus 3 is 203. Obviously, that's not going to work. Let's try negative 10. So negative 10 plus 10 is 0. 0 plus 3 is 3. And negative 30 is negative 40. So that does not work either. So we have exhausted all of our real roots, our rational roots, which means that if we were to solve this, we would either have complex or radical roots, okay? So make sure when you're doing this, you're doing your synthetic division to find out if the remainder is 0. If it is not, then it's not a root and you can move on to the next one, okay? Which we're going to do. So here we're going to take the factors of 18. I'm going to write all of them out here. And we're dividing by the factors of 1, which clearly are the same numbers, okay? We're going to kind of do the same thing. We're going to go through. Our goal is to find a root that ends up with a remainder of 0. So I'm going to start with my 1s. 1 times 1 is 1, minus 2 is negative 1, negative 1 plus 9 is 8, and 8 plus negative 18 is negative 10. That doesn't work. So I'm going to try negative 1. Negative 1, negative 2 is negative 3. 3 plus 9 is 12, and negative 12 plus negative 18 is negative 30. So the ones are out. Now we try the 2's. 1 times 2 is 2, plus negative 2 is 0. 0 plus 9 is 9, and 2 times 9 is 18, plus negative 18 is 0. So we found our first root, x equals 2. Now we take what's left, which is x squared plus 9. Now this should look familiar. When we talked about complex roots, we talked about every time we multiply them together, we end up with x squared plus a square number. In this case, 9 is the square of 3. So I could solve this by square rooting. That's one way to do that. And you would get x squared equals negative 9, so x equals plus or minus 3i. You can also know that x squared plus 9 is x plus 3i and x minus 3i. If you factor it, therefore x is equal to, again, negative 3i and positive 3i. I don't really care how you think about it, as long as you do, and you know that this is going to be plus or minus 3i for your remaining two roots, okay? So complex roots can be pretty easy to find once you get there, but finding that first real root is the way to go. So set up your possible roots, use your synthetic division to divide, figure that out, and then you can find out what's left, okay? Now to one of the writing the polynomials. Least degree, leading coefficient of 1. That's always going to be the case, okay? Now look at the roots that I've been given. I've been given 3i, 5, and negative 2. Remember that if you have a minus 3i, you also have a plus 3i. Don't forget the conjugate. That's super important, okay? So I actually have 4 roots here. This is going to be a 4th degree, which I hope you know is called a quartic. I'm going to multiply these first two, and I get x squared plus 9. I hope you've got that shortcut down of how to multiply the complex roots where you don't have to actually multiply it out. It makes life a lot easier if you can do it mentally, okay? Same with this one. You can use the box to multiply x minus 5 times x plus 2. You should get x squared minus 3x minus 10. Now I'm going to multiply these two together. So I'm going to multiply x squared plus 9 times x squared minus 3x minus 10. This, again, is where that box comes in really handy because I can do a 2 by 3. And I've got x squared and 9 on the side. X squared minus 3x minus 10 up here. And I'm just going to go through and I'm going to multiply all of the pieces. And then I'm going to combine any like terms. So I'm going to get f of x equals x to the 4th minus 3x cubed minus 1x squared minus 27x minus 90. That is my polynomial of least degree with a leading coefficient of 1 with those roots. Okay? Hopefully this helps you get ready. And if you have any questions, we'll go over these. You're welcome to chat with me, especially if you're not in class for the review. Shoot me an email and let me know what questions you have as you are preparing for this